The focus of this video will be to review key concepts of what a type 2 binary non-acid ionic compound is. Furthermore, I'm going to work multiple problems going from formula to name. At an introductory chemistry level, a type 2 ionic compound contains a metal that can have more than one common charge. A type 2 includes most transition metals and the metalloids germanium and antimony. The charge of the metal is usually shown with a Roman numeral in parentheses. By the way, the six-pack is not included in the type 2 compounds. And only if all subscripts have a common factor greater than 1. You must divide all subscripts by the greatest common factor, also known as GCF, to obtain the lowest whole ratio number. Like I have mentioned previously, type 2 cations include most transition metals and the metalloids germanium and antimony that are shown in blue. When looking at this example, we can clearly see that a type 2 ionic compound can contain a metal that can have more than one possible charge. Remember that the number written in Roman numeral inside the parentheses represents the charge of the metal. The charge of the metal. Okay, let us go from the chemical formula to the chemical name. This is a type 2 multiple charge metal, and it's a binary non-acid ionic compound. The first step is to name the first element or polyatomic ion. So I know I'm looking at an element which is copper. And the second step is to name the second element or polyatomic ion. And if it's an element, we're going to change its ending to IDE. So instead of saying oxygen, I'm going to say oxide. The third step is to determine whether the first part falls into a type 1, type 2, or a type 3. Remember that we're doing a type 2, so that is one with a multiple charge metal. Sometimes it can be germanium or antimony. It definitely cannot be a type 1 because it's not a fixed charge. It doesn't have a fixed charge, and it cannot be a type 3 because it's not a non-metal. So if it's a type 2, you're going to add parentheses. Now, the fourth step is to create a T-chart and write the chemical symbols for each element. Copper, remember, is Cu. And oxide derives from oxygen. Now, the next step is to write the subscripts based on the chemical formula. I have a 2. I'm going to bring it over. And there's a 1 understood here. Now, you can either remember from memory or use your periodic table and write the charge of the anion, which is -2. Now, we need to find the charge of the cation by making sure the total charge of the compound balances to 0. So 1 times -2 gives me -2. And then 2 times what number is going to allow me to have a number where I say that number -2 gives me 0. It's going to have to be a 1 in here because 2 times 1 gives me 2. And then 2 minus 2 gives me 0. So our final step is to write the charge of the cation in the form of a Roman numeral inside the parentheses. For the simplicity of visualizing everything correctly, I'm just rewriting what I had on the top. And the number that goes inside the parentheses is going to be the charge of the cation in a Roman numeral. And that's going to be my answer, copper 1 oxide. Okay, so now we're looking at this chemical formula and we need to find its chemical name. Remember that the first step is to name the first element or polyatomic ion. I know this right here is tin. The second step is to name the second element or polyatomic ion. And if it's an element, remember we're going to change the ending to IDE. So instead of saying chlorine, we're going to say chloride. Now, we need to determine whether the first part is a type 1, a type 2, or a type 3. And I know I'm looking at it a type 2 because it's a multiple charge metal. And also because I'm able to find it here in the periodic table. There's my 10SN. So if it's a type 2, remember we add parentheses. Our fourth step is to create a T-chart and write the chemical symbols for each element. So basically what you're doing, you're transferring the information over here. Now, we must write the subscripts based on the chemical formula. There's a 1 understood here, so I'm going to write it over here. And then there's a 4. I'm going to bring it over. Our next step is to determine the charge of the anion, which is a -1 because it's in group 17. Now, to find the charge of the cation, we must make sure the total charge of the compound balances to 0. So 4 times -1 gives me -4. And 1 times what number will give me a number that when I say that number -4 gives me 0. It's going to have to be a 4. 1 times 4 gives me 4. And 4 minus 4 is 0. The last step is to write the charge of the cation in the form of a Roman numeral in the parentheses. So remember how we write our Roman numeral 4? It's going to be like that. So my chemical name is going to read tin 4 chloride. So notice that this compound is a little bit different because instead of having a transition metal, we have a metalloid, and it's one of the ones that I told you to remember, which is antimony. So if it's found within the blue region, that makes this compound a type 2. So remember, the first step is to write the first element or polyatomic ion, and this is an element, so I'm going to write antimony. The second step is to name the second element or polyatomic ion. It's an element, so I'm going to change the ending to IDE. So instead of saying sulfur, I'm going to say sulfide. We already determined that it's a type 2 because at the first part, the cation happens to be antimony. So therefore, we need to have parentheses. Now we need to create the T-chart. We need to bring the information down. We need to bring down their subscripts. Now I need to find the charge of the anion, and that's going to be a -2 because it's in column 16. The next step is to make sure that the total charge of the compound balances to 0. 3 times -2 gives me -6. And then I need to have a number in here to make this statement where it says 0. So I'm going to write a 3 in here. 2 times 3 gives me 6. 6 minus 6 gives me 0. Now, the last step is to write the charge of the cation in the form of a Roman numeral inside the parentheses. This cation, I'm going to write it in here. That's going to be a 3. And my final chemical name is going to read antimony 3 sulfide. So I already worked this example. You can stop it and you can try yourself. Remember that the first thing that you do, you name the first element or polyatomic ion, and then you name the second element or polyatomic ion. If it's an element, you're going to change this into IDE. Afterwards, I determined that the first part falls in the blue region, so therefore it's a transition metal type 2, so it uses parentheses. The next thing that I did, I make sure that the total charge of the compound balanced to 0 by bringing in the subscripts, by finding the charge of the anion, and by figuring out the charge of the cation. So with that being said, you should have gotten nickel 2 chloride.